Welcome everyone to our second session with SEA's Sailing Symposium on North Atlantic right whales. And we are just north of Cape Hatteras, sailing in the Gulf Stream, still aboard the Corwith Kramer, coming to you from the quarterdeck. So today we'll be hearing from Amy Knowlton, senior scientist at the New England Aquarium. So without any further ado, let me turn it over to Amy Knowlton.
It's great to be here. I don't know if I've told everybody this, but I was a student back in 1980 on the Westward, W52. So this is very special to be back here again, and I really appreciate the invitation. So I've been working with the New England Aquarium since 1983, and I was asked to sort of talk about how I got into right whales, and I think maybe I was predestined to study this species because when I was 8 years old, I made these sculptures for my father of a mother and calf, what I think is a very good likeness to right whales. So maybe, I didn't know anything about right whales at the time, but perhaps it was in my brain somehow. But so when I went to college, I started learning more about environmental issues and options, and when I went to Boston University and looked in the course catalog, I came across the Sea Education Association and their offerings, and I was hooked because I had grown up sailing. I loved the ocean, I loved wildlife, so when I learned about that sea semester program, I joined it in 1980. And then after I finished college in 1982, I began volunteering for the aquarium in 1983. And without knowing that there was actually a right whale program, they put me on that program because of my Sea Education Association experience and my knowledge of operating vessels. I didn't know anything about whales, but that was not needed to join the team. So I started in '83, and I've been with them ever since. But I want to talk today a bit about what we do at the aquarium, which is really focused on monitoring this species, this critically endangered species. As you heard yesterday, they're down to 340 individuals. And just to give you a sense of what's been happening for the species, this is back in 1980 when I started. There were just under 300 individuals, and they crept up over time at about a 2% growth rate to just under 500 individuals in 2010. But since that time, they've sort of been in free fall, and now they're back down to 340 individuals. So the question is, what's going on for the species? So the way that we monitor right whales is through the photo identification catalog. We collaborate with a lot of scientists up and down the eastern seaboard of the US and Canada. And at the New England Aquarium, we curate the photo identification catalog for right whales. Right whales have the natural markings on their head, as we learned about yesterday, the callosities. Here's a bigger, better right whale. But you can see that these callosity patterns are unique to each individual. And here's just two images of two very different looking callosity patterns. And we have an elaborate software system that helps us monitor the individuals. And through that collaborative effort, which is sure, through the collaborative effort, which is sort of under the umbrella of the North Atlantic Right Whale Consortium, we have really collaborated well as a variety of different research groups to share data and to share findings and to make sure that the data is well used and well coordinated. So in addition to just keeping track of the individuals in the population, part of my focus has been to look at the human impacts that right whales are facing. Right whales are prone to vessel strikes and to entanglements in fishing gear. The vessel strikes either result in death through blunt force trauma or sometimes death from propeller cuts, and sometimes they survive those propeller cuts. This is just to show you three different levels of severity of those cuts. We have deep, shallow, and superficial cuts. And I'm working on a project right now with a fellow in the West Coast to look at do some forensic assessments of propeller cuts and see if we can determine the vessel sizes involved in these strikes. We have some knowledge of that, but we're trying to expand that knowledge to help managers understand what vessel strikes are leading to those injuries that can result in death, which is typically the deep cuts. The other aspect of what I've been focused on is looking at entanglement rates and monitoring each. Myself and a team of folks at the aquarium review every photograph sighting of individual right whales taken each year to look for evidence of wrapping scars on their body or tail, or evidence of carrying attached fishing gear. And we've been keeping track of that since 1980, and we have minor, moderate, and severe injury levels.
I don't think they can see it.
Oh, sorry. I'm sorry. And I'll leave this in the science lab after we're done. But anyway, you can see 3 different levels of severity for entanglement injuries. Here's just a couple of case studies I wanted to share with you of one lethal entanglement, which involved a 2-year-old male that got entangled in lobster gear up off the northeast U.S. and swam to Florida before he died from that entanglement. It was able to be linked back to the northeast U.S. because of marks on the gear that showed where it was from. This was another case study. This was a whale that was a young whale when it was first seen with gear wrapped around his head, sort of tightly wrapped around the head. We tried to disentangle this whale, but unfortunately the rope was just too tight to get a knife under it to cut it. And so that whale lived for 3 more years, but as you can see, he grew into the rope, it cut into his head, and he eventually died from that entanglement, disappeared. That happens, unfortunately, all too often. Here's a graph of entanglement numbers from 1980 through 2020. And these are categorized according to minor, which is in green, moderate in orange, and red is severe. And what you can see here is that over the decades, things have just progressively gotten worse. We're seeing a lot more severe entanglements than we ever used to. In the 80s, when I started working, it was rarer for us to see any entanglements, much less severe entanglements. But now you can see through these red bars that it's just become a more common issue for this population. So we believe that that is part of the reason that this population is in free fall since 2010, because of this escalating level of severe entanglements that lead to mortality. So another aspect of what we do is look at the health of individual right whales. We look at 4 different parameters: their body condition, skin condition, and a couple of other visual cues about their health. And so this is the same individual. On the top, it's a healthy looking whale. On the bottom, it's been entangled, it's got rope through its mouth, and it's looking in very poor skinny condition, and that whale eventually died. So by looking at the health, we are able to then look at health in relation to entanglements. We look at health in relation to calving events. We can look at health related to a variety of different parameters and try and understand what things are influencing that health. So we got a paper published recently looking at the health related to the severity of the entanglements by reproductive females and all others. And what you can see here is in the gray bars is the reproductive females, and their health declines as the severity of the entanglement increases, so going across. Whereas the other whales, also the health declines, but not as dramatically as the reproductive females. So you can see that they are much more negatively impacted by entanglements than males and non-reproductive females. So that's not a good sign for this species. Here's another look at health by decade. We wanted to explore how much of a role food limitation might be having on the species, because there's some concern that we know that the distribution of right whales has been shifting since 2010, and it's probably in relation to food availability. So we wanted to explore how much of a role that could be playing in their declining health. And what we can see is in the white bars, for each decade from the 80s through the 2000s, the white bar declines slightly, but when you go to the minor, moderate, and severe injuries, they decline much more dramatically. So you can just see that the entanglement effects on health are causing a much greater role in right whale decline than any food limitation might be having. So that's why we're trying to figure out ways to prevent this problem. So one thing that I've been trying to get an understanding of is how the industry has changed over the decades, because why are we seeing more of these severe entanglements? And it's a little bit hard to tease out, but this is a graphic showing lobster landings in 1967 and in 2014, and you can see that landings were high sort of along the offshore waters of the mid-Atlantic and somewhat of the Gulf of Maine, but by 2014 they had grown dramatically in the Gulf of Maine and still present in the offshore waters as well. So there might be some linkage there to that. There's perhaps increased effort, increased ropes, more overlap with where the right whales are foraging.
Is the landing where the pot was dropped and then brought up?
Yeah. Yep. The other thing that we explored was rope manufacturing. And this was a really interesting finding because we worked with a rope engineer who's written a book about rope fibers and rope manufacturing. And we learned that prior to the 1950s, there were no plastics really in our world. And so fishermen were using hemp rope, manila rope, natural fiber ropes, and which are shown here in the green bar. This is by rope diameter of 3/8 inch to 3/4 inch. Starting in the 50s, when they developed plastic polymers, they started making polypropylene ropes, which are shown here in the yellow. So again, pretty good dramatic increase in rope strength in these diameters. But what was the most interesting is that in the early 1990s, they developed a new process called co-extrusion for blending plastic polymers together and creating even stronger plastic fibers that were used in rope making. So there's a rope company called Polysteel that brags about having ropes as strong as steel. And that's the ropes that are used in the fishery more routinely because they last a lot longer than even the old polypropylene ropes. But you can see there's a dramatic increase in the breaking strength shown here in the red bar. So back in 2016, I published a paper along with a rope engineer and some other folks looking at the rope strength of retrieved ropes from 70 different individual whales, 4 different species: right whales, humpbacks, fin whales, and minke whales. And we looked at the polymer type and the diameter and determined what that rope strength would have been when it was manufactured. And that's what we compared across the species. And what you can see here is we came up with 2 very informative patterns. One is that the smaller species, the minke whales, which are shown here in the red triangles, were in the lowest breaking strength ropes than all of the other 3 species. So they didn't have the strength to break free from the stronger ropes. And then when we looked at right whales specifically, what we learned is that the 0 to 2-year-olds, shown here in the red diamonds, were in the lower breaking strength ropes than the adult whales. There was a dramatic difference between the 2 age groups. And as a result of this study, we made a recommendation in our paper that if rope strengths could be reduced to 1,700 pounds, that we could perhaps prevent some of these lethal entanglements from occurring that we've been seeing an increasing frequency of. So that's what's shown here in the orange line that's the threshold we chose because it was below the majority of the entanglements that we've looked at from that retrieved gear cases. So these graphs just show that in a little more detail if you want to take a closer look. I'll leave this in the science lab after I talk. But anyway, this has been an important finding for management efforts, and Colleen might talk about that a bit. 1,700-pound ropes are starting to be used in regulations in both the U.S. and Canada. Massachusetts actually has required, in addition to the closures that are off the coast of Massachusetts, they also now require weak ropes during the rest of the year, weak ropes with weak insertions every 60 feet in their end line. And so that's a big change for the fishery, but they are able, we did a lot of trial work with them using, testing these contrivances, weak contrivances, and it really, they've been able to make it work for them. And I just want to show you what the fishermen, when we published our paper in 2016, showing that rope strength was an issue, fishermen in Massachusetts who had been shut out of their fishing area, thank you, were, oops, they came to us and said, you know, we would like to figure out a way to get back into our fishing zones, but, and they had read this paper and they came up with this idea of a weak sleeve. They worked with a rope manufacturer to create a hollow braided rope sleeve that was tested to break at 1,700 pounds. And they insert it into their existing rope, so they cut the rope and they sort of feed this in, and right in the middle is the break point of 1,700 pounds. So it's pretty cool that fishermen came up with this idea, and fishermen are continuing to create weak contrivances to trial in their fisheries and see how they can maybe make something that's a little easier to insert in their ropes. And so they're making great headway with that. And I think that the only limitation of weak rope is that in deeper waters where you're hauling heavy gear, it may be not feasible to use this, because if the tension applied to the gear is much higher, and they could lose more gear as a result. So it has limitations on where it can be used, but it's a really, I think, a valuable tool to help try and reduce the risk of a lethal entanglement from occurring. The other tool that I think Erica will talk a bit about tomorrow is what we call on-demand gear, or ropeless fishing gear. And that's basically, the goal of that is to take the rope out of the water column until the fisherman needs it and can release it with an acoustic release and have it come to the surface. So that's the ultimate solution to really eliminate entanglements. This is preventing lethality of entanglements. They will still occur, so it's not considered the best option ever, but it's certainly an interim step that we feel is important to get into the industry to help them keep doing their work without harming whales. So that's really what my focus has been. I'm trying to think what else I should share with you. Yeah, I think that's...
Did you see your first right whale?
Oh, my first right whale. I saw my first right whale in the Bay of Fundy in 1983 when I started with the aquarium's research team. We had a field station, we still have a field station up in the Bay of Fundy, and I would go up there every summer. For 40 years I did that, until the right whales decided not to use the Bay of Fundy anymore. So right whales have been, as I mentioned, they've been shifting their distribution starting in 2010. It's made life complicated for the researchers trying to keep up with where they are, and you know, sometimes they're much further offshore, so we have to use bigger boats or use aerial surveys to help find them. Acoustic detections, which Lindsay will be talking about, have been really a valuable tool to help us understand where they are when we can't have surveillance out there. And so there are other tools that help understand where right whales are shifting to, but it's taken a lot to try and keep up with the species. And you know, I feel that time is of the essence. The species could go extinct within decades if we don't address these threats that they're facing, especially the entanglement threat, which has been escalating. So we really are working hard with the industry, hard with the government, to try and come up with solutions that can work for the industry but also help the whales. So fingers crossed that we can keep that momentum going and make some headway in the years ahead.